part of this graph. Find the coordinates of the local minimum point. Well, on my calc paper, as soon as you see a function like this, draw it on the calculator. So y equals negative 2x to the power 3 plus 5.1 x squared plus 3.6x minus 0.4. Okay, we don't know what these values are, so I'm just going to use my standard axes. And there we've graphed it. So it kind of looks like this, can't see everything. Ideally, perhaps we would be changing the scale, so perhaps change the view window so we can see a little bit higher on the Y. So perhaps we'll have our max at 15. Okay, now it says find the coordinates of the local minimum point. You may not remember what a minimum point is, but looking at this picture, I would hope that even any of you would stab a guess at this one being the minimum point. But even if you hadn't remembered, you could do this. You could do calc, so second calc, and you're finding the minimum point. So that's 3. Now the left bound of the minimum point. So we need to be on the left of the minimum point. It says right bound, so we need to go to the right of the minimum point. It guesses and then finds that minimum value of, no, I have to remember, so we're going to round that, so it's negative 0.3 and negative 9.967. Okay. So the graph of f is translated to the graph of g by the vector 0, k. So this tells us that it hasn't moved left or right, it's only moved up and down. Find all the values of k so that g0 has exactly one solution. So we have a look here and we've got to say we need only one solution. Well, if I were to draw a horizontal line through here, I would have 3 solutions. If I were to draw a horizontal line through here, I would have just one solution. If I were to draw a horizontal line through here, oh darn it, I would have 2 solutions. Okay, so we want to shift this graph up or down so that we have only got 2 solutions when it's equal to 0. So in other words, it only crosses this axis here. One solution. So it can only have one solution when it crosses this axis. So essentially, hopefully you realise you need to shift it up this amount. There's 1 at the times. Okay, because it has to be shift up by this value. We found this value to be negative 0.967, and so our value of k has to be greater than 0.967. There's 1 of them. So k has to be greater than 0.967 in order for us to have just one solution. However, it could also shift down. So we need to also find this point here. So we thought we'd finish with the calculator, but no. So we're going to do second calc. This time we're finding the maximum. So oh, I think I hit it too soon. Right, let's try again. Calc max. So left bound. So hit up here. Left bound. Right bound. And we found that that maximum is at 2. Oh, the x value is 2 and the y value is 11.2. Okay, so we know that k has to be less than negative 11.2 because our graph would have to shift down by at least 11.2 units. So there's that answer there. Okay, so binomial expansion question again. Okay, we should be getting good at these. This one's a bit tricky though. Let's find this. So we've got it. Okay, so we know we're using this as our general expansion. This is where you've got to be very careful. This value, this part here has been multiplied by this whole bracket. Okay, so when we have done this expansion, so if we were to expand this whole thing here, that's all to power 11. No, it's just this bracket that's to the power of 11. So if we were to expand that in the usual way, we would use this expansion here, and so on and so forth. We focus on our second term. Oh, it's getting a bit loud. So we'd focus on our second term and look for when the power was 5. However, we are not going to look when the power is 5 because we're going to be ultimately multiplying our terms of this expansion by this term here as well, this part here. So in order to get the power of 5, we actually are focusing on, we want the power of this expansion to be 2. Because we know that when we multiply terms with the same base, we would add the powers. Equally, we would want to... Yeah, so there we go, okay? So, we're using this here, we've got 11r, 2 to the power of 11 minus r, ax to the power of r. So we need our value of r to be 2. So we've got 11, 2 to the power 9, ax to the power 2. So we're going to find out what these values here are. So calculator, NCR, so that's, oh, what's come on here? Darn it. Okay, so oh Lord above. So we're finding 11, 2, so it's 55, multiplied by 2 to the power 9, which is 512, multiplied by a squared, okay, x squared. Okay, so that's that term. And then we're multiplying that here by ax cubed. So we're multiplying that now by ax cubed. And when we do that, we see that our powers add together. And we're going to have 55 multiplied by 512 is 28160. A cubed x cubed. Okay, so they've said that the coefficient of the x cubed, sorry, what am I doing, x cubed, x5. They've said the coefficient of the x5 term is 11880. So that means that 28160 a cubed is 11880. So a cubed is 11880 divided by 28160. 11880 divided by 28160. 160, and then we're going to cube root that. So number 4. Cube root the answer. So that's 3/4. Done.